Alright, this video is going to be about balanced and unbalanced forces and calculating net force. Calculating net force. That's what we need to learn next. Net force. So before we get started, we'll do a quick review. So everybody by now should know what a balanced force is. Remember, this all goes back to Newton's first law of motion. Balanced forces result in what? No change in motion. Whatever the object is doing, it will continue doing. Meaning if it's moving, like our Earth, it will continue to move. If it's not moving, it will not start moving. Balanced forces, no change in motion. Unbalanced forces. These are the ones that change motion. Meaning if I'm not moving, I will start moving. If I am moving, I may slow down or speed up or stop. They change motion. So these change motion. Okay? Whereas balanced forces do not. Okay, so how are forces calculated? Well, forces are calculated using the unit Newton. And units called newtons. And why would they be calling them newtons? Well, who was the guy who came up with these laws of motion? Yep, you got it, Sir Isaac Newton. So that's why we call the unit a newton. Okay? Or newtons. Okay. Let's go back to a little image here and talk about it for a second. So we had talked about this scenario in Newton's first law of motion. So when we talked about balanced forces, because as you can see here, here's our good old game of tug-of-war, and the forces on either side are equal, right? These are equal forces on either side. So, and you can also see that these are opposing forces because one group's pulling in one direction, the other group's in the other direction, right? And they're opposing forces, so they're opposite. So, what do you predict is going to happen here? Well, if you said they're not going to move, you're absolutely right. Because if I'm pulling in this direction with 300 newtons and you're pulling in this direction with 300 newtons, these forces are going to cancel each other out. And now we're left with the net force. If we wanted to calculate, well, what's the net force here? Well, we had 300 newtons to the right, and we had 300 newtons of force to the left. Since they're opposite in direction, we need to subtract. And that leaves us with how many force, or how many newtons of force? Leaves us with 0 newtons. So the net force is what for this? What's the net force operating on the rope? 0 newtons. Okay. So this is how you calculate what's actually happened and what's the force acting on the object. All right, let's look at another scenario now. In this scenario, you can see this group is still continuing to pull with 300 newtons, whereas this group is pulling with 400 newtons. They're still in opposite directions, so they will be subtracted. Anytime you have forces working in opposite directions, It means subtract. Because they're working against each other. So let's see here. If we have, we're going to always take the higher number, 400 newtons. The direction this is moving is to the left. And we have minus the opposing force, or the force working opposite the 400 is the 300 newtons, and it is working to the right. So I come up with net force. So my net force is going to be 100 newtons. And in what direction? Is it moving right? No, that was a smaller force. Always in the direction of the larger force. 100 newtons to the left. Alright, so how are we feeling about this? Let's try a couple more and see how we're feeling about this. Alright, so let's just try some practice problems here to get you a little bit more comfortable with working and calculating net forces. Alright, this scenario says Nemo is trying to swim upstream to be found again. He pushes forward with a force of 2 newtons. So I'm going to say he's going this direction, so that's his forward. His forward's going to be to the left, so he's pushing forward with 2 newtons of force. But the stream is pushing back on him. So I mean the stream is working against him here. So the water is pushing in this direction against him with a force of 2 newtons. Alright, so what's going on here? First of all, are the forces balanced or unbalanced? Well, are they equivalent forces? If they are equal forces, they're balanced. But, as you can see, they're working in opposite directions. So if I wanted to calculate the net force, remember we said if they're working in opposite directions, you must subtract. So 2 newtons minus 2 newtons, 2 newtons to the right, 2 newtons to the left, gives me how many newtons? 0 newtons of net force. So when I come up with a scenario where the answer to my calculation is 0 newtons of net force, the forces are balanced. Nemo's not moving, even though he's moving with 2 newtons, but the stream is pushing against him equally. So he's really not moving. The forces are balanced. Will he accelerate? Meaning, will he speed up, slow down, change direction? Will he do any of that? No, he will not. He will not change anything. His speed will not change. His direction will not change because the net force acting on him is 0. So forces are balanced. There will be no change in motion for Nemo. Alright, so let's look at another scenario. How about this one? Here are people standing on the beach. They're not moving. As you can see from the force arrows, they are both equal and they're working against each other. So literally we have 50 newtons of force going up and 50 newtons of force pushing down. So what is the net force? Since they're in opposite directions, I must subtract. So the net force ends up being 0 because 50 minus 50 is 0. So we have a net force of 50 newtons. There's no change in motion. And when there's no change in motion, the forces are, you got it, forces are balanced. All right. So anytime you are standing, the force of the ground is pushing up with you equal and oppositely. That allows you to stand and not fall through the ground. All right, we're going to try another scenario. Let's go back here and try another scenario. let's say we have a box, and I've asked you to actually help me move this box because it's way too heavy for me to move on myself. So I asked you to help me move, and we're going to try to push this box across the floor. So I don't have very much muscle left, so I'm pushing maybe with a force of 10 newtons. You, on the other hand, are nice and strong, and you're pushing with a force of 15 newtons. Now notice what's happening here. Now we're both using forces, and we're pushing against the box in the same direction. So now if we're pushing in the same direction, we are working together. Right? We're working together to move this box. So now what's the net force acting on the box as we both push it? Well, if we're working together, we're going to add the forces. So if the arrows are going in the same direction, you must add. And so let's add them up. So we've got 10 newtons, and we're both pushing to the left, and 15 newtons to the left. This gives us a net force of 25 newtons to the left. Is the box moving? Yes, the box is moving. So has the box's motion changed? Yes, it's changed because it was standing still. Now it's moving. So we have a net force of 25 newtons to the left, and this is an unbalanced force because unbalanced forces change motion. Alright, and that was it for our workshop on balanced and unbalanced forces and calculating them. If you need any additional help, feel free to see your teacher or myself. Thanks.